things we have completed in our previous sessions, and I hope you have also watched the recordings or the live sessions you have joined, right? So, any doubts or any queries in the previous sessions? Shall we start with a new topic that is interface? Yes. Okay. I hope everything it is clear, right? Yeah. So, let us start this session. Now, so before going to start about interface and all, let us have a requirement, and using that particular requirement, we will go and see why we are going to use an interface. Okay. So let's say if I have a top model like this, and in this particular module, I am going to have different particular modules. This is module 1, and this is module 2 I'm going to have, right? And in this particular module 1, what I'm going to do is, let's say it is following some XYZ protocol. Okay. Let's say it is following some AHP protocol. Okay. Where this is my master and this is my slave. Okay. So no need to worry about AHP protocol, APP protocol, something. Just we are going to use some things. Let me show you what I'm going to use. So here it is going to send a signal which is known as valid. Okay. Or let's say it is sending a signal ready, and the slave is sending a signal which is known as valid. Okay. Or let us say if we have a top model where we have my master and a slave. Let's say if the slave responds to my master as ready, the master will send the data, valid data. Okay. This is nothing but my handshaking mechanism which I'm going to have. Okay. Now, next master will send the data. Let's say this particular line, which is known as W data, and this slave will send the data to the master using some other line, which is known as R data. Okay. So master will send the data to the slave using W data, and the slave will send the data to the slave using R data. Okay. And let's say if the master wants to perform the write operation, it is going to use something known as W let's say A, right? Just I'm using some random signals. Okay, don't worry about this particular things, right? And let's say if the slave wants to give the response to my master, it is going to use response signal. Let me draw it more clearly. This is my master and this is my slave. This is my master and this is my slave. So master gives the slave the valid signal, and the slave will give the master a ready signal, and the master will tell the slave that it wants to perform the write operation using write signal, and it writes the data using the some EW data signal or W data signal, and the slave will write into the master using some R data signal. Okay. And also response to the master using some response signal. Okay. So this is how your master and slave are going to communicate with each other, and they are basically instantiated in one more top model. Okay. So like this, your master and slave you are going to uh, are going to be connected, right? Now in Verilog, if you want to do this particular connection, you are going to use either connection by name or connection by order you are going to follow. And in master, you need to declare the signals. Let me show you. So inside your master, you need to declare the signals as valid. Okay. And what else you have? Write and W data as your outputs. Okay. Using your output keyword, you need to declare them inside your model interface, and the ready signal. And what else we have? Our data signal, our data signal, and our response signal. You need to declare them as input. What is the logic of the signals? We don't care, but just I'm giving an outline. If the master is having these signals and slave is having these signals, if you want to connect, you need to declare the signals in your master as output and the signals as your input. And in the slave, you need to declare the signals in the vice versa order. Okay. So valid signal, write signal, W data signal, you need to declare them as inputs, and R ready signal, R data signal, R response signal, you need to declare them as outputs inside your slave. And inside your top model, you need to again declare these signals. Okay. Now, can anyone tell me in the top model, what should I using which data type I need to declare the signals, valid, write, and W data, using rich or using wire? Can anyone tell me? So in my top model, all this valid signal, write signal, W data signal, using which data type should I declare them? Reg or wire? Okay, so they are basically outputs to your master, right? And they need to be connected to your slave. And if you carefully observe the diagram also, you need to have this particular connection. Valid is being connected from master to slave. Now tell me wire. Exactly. Okay. And ready also. So this and all signals should be connected as wire so that you can make this particular connections. Am I right or wrong? Yes or no? If you are going to have this signals declared them as wire, then only you can make these connections, right? Okay. Wire is the only data type which you can use for making the connections between the two models, right? So in the top module, you're going to connect this signals as wire. Okay. Now in system, this is in Verilog. Okay. And in system Verilog, if you want to declare the signals, you can use logic data type. Okay. Yes. Now, so how many times are we declaring the signals in top module? Also, we need to declare the signals again. We need to declare it again. How many times we are declaring the signals? Can you tell me? Three times we are declaring, right? So in master, we are declaring the signals. In the slave, we are declaring the signals. And the top also, we are declaring the signals again. Okay. And we need to follow. Now, where we are going to make these connections? In which model? In the master, slave, or top model? I hope everyone knows and everyone know how the basic prerequisites of Verilog, right? Exactly. In the top model, we are going to make these particular connections, right? So this is here how many signals I have? One, two, three, four, five, six. Only there are six signals. So our job is a little bit easier. But let's say if you have 50 signals, okay, and if you have five to six modules, then your job is a little bit difficult, right? So if you miss any particular connection, then obviously you're going to get unexpected results or wrong results. Okay. Now, in this particular case, we are going to use interface to to make our job easy. Okay. Let's say if I have a simple device, let's say this is my device A and this is my device A. From this device A, I am getting four lines. Okay. Four lines which I am going to get, and this is red line, blue, green, yellow. Okay. And this also have red, blue, green, yellow. B, G, Y, and here also I have R, B, G, Y. Okay, this is case one which I have. Now in the case one, you need to connect the red line with red line, blue with blue, G with G, and yellow with yellow, or else this will blow out. Okay, this is the case one which we have, and in the case two, we have a device A and a device B. And if I want to connect these two devices, I'm going to have something known as a already predefined port or an interface. Let's say this is some HDMI interface or USB interface. I'm not exactly naming that particular interface. Just it's a set of interface. All the bunch of wires are already present over here, and this has already been packed. Okay, this is some XYZ interface. Okay, so if you want to connect them, you are going to make them make their connection. That's it. Instead of connecting them by wire, you are going to use this particular packed interface, and already the lines are already have present in that particular interface. You are just making the connection from the top. That's it. Is it clear, guys? Can you able to differentiate between case one and case two? Yes. And okay, yeah. So this is what the same mechanism which we are going to use in our interface. So interface is nothing but a bundle of signals. So we are going to declare all our common signals which we are going to use in our project inside our interface, and we are going to use that interface across our project. That is what we are going to use our interface for. Okay. So let's see how to use it. Let's say if I want to use an interface, I'm going to use a keyword which is known as interface. This is a keyword which I'm going to use for declaring an interface. Okay. And interface followed by interface name. Okay. And if this interface needs to get any arguments from the top, it can have the arguments list. Okay. This is optional. and you need to declare whatever the signals you wanted to use across your project. That particular signals you need to declare over here. Okay, so you need to declare all your signals over here. That's it. This is how you can use your interface, and followed by end interface. And interface. This is written outside your module. Okay. So interface followed by interface name, and followed by the optional arguments which you can have for your interface, and declare all your signals with their data types which you want to use across your project, and followed by end interface. That's it. Okay. And there is no space between end and interface. Okay. Now let's say in this example we have two modules, master and slave. Okay. Now what I'm going to do, I'm going to declare my master or module 1. Okay, so I'm going to declare simply module. Before that I need to declare my interface, and interface followed by interface name is inf. Okay, inside this I need to declare all these signals as logic. I'm going to use them because why I need to use logic, why I'm not using reg or wire here. If there are many models, all those can be declared. What you want to declare, Bhunesh? Okay. So in the interface, why I'm using the signals, why I'm declaring the signals with logic keyword? Can anyone tell me? So I'm going to declare all the signals with logic keyword, valid and w data. I'm not concerning about the width and width of that particular signals. Just this is an example, right? Logic right. Okay, I'm declaring all the signals which are present, all the six signals which are present. Okay, all the signals which are present, and followed by end interface. Why I'm going to use here logic? To avoid reg and wire confusion, exactly. And also this valid can be output to your master, and it can be input to your slave, right? Okay, if it is an it can be output to your master. If it is an output to your master, you are going to use it in your master, right? So in your master you are going to use it in a procedural block, right? So yeah, we can use both wire and reg operations, exactly. Okay, so that is why we can use it in we can declare it as logic. Okay, now what are we going to do is in our module master, instead of declaring this particular signals, I can simply write down my interface name. Interface name is INF, and my interface instance I need to have. Let's say it is IENF underscore M is my interface name. That's it. Okay. You don't need to declare any particular signals inside your when you are declaring your master arguments. Just write down the interface name followed by interface handle name. Okay. Now inside your code, let's say previously inside your master when you are writing, let's say you are going to write within an always block, valid is equal to 1. This is what if you were writing. And here uh, in your slave within an always block, let's say if you are going to write if valid is equal to 1, ready is equal to 1. This is the logic. Let's say you are writing. Okay. Now, let's say when you are going to use interface, what you are going to do is you are going to use your interface instance name within an always block. What you are going to write always with using your interface instance name, that is inf underscore m dot, you are referring to this signal which is known as valid. Okay, and what you're going to make it, you're going to make it 1. Inf underscore m dot valid is equal to 1. That's it, and followed by end model. That's it. So you're just referring to this valid signal but using the interface handle name. Okay, now inside your slave also, what you're going to do, module slave, you're going to use your interface name, that is inf, and instance name, let's say it is inf underscore sl is my interface handle name. Okay, and within an always block, what is the logic we have written? If inf underscore sl dot valid, I'm referring to this valid signal using the interface instance name, interface handle name. Okay, and followed by what I'm going to write down here, if it is equal to 1, then inf underscore s1 dot ready is equal to 1. This is a simple code which I've written. Okay, and followed by end model. Is it clear, guys? If you are using this particular interface, you need to declare this you need to first of all declare the interface instance inside your arguments of your module, and you need, if you are referring to the signals, then you need to use the interface instance name for referring to those particular signals. Okay, so without declaring the signals you cannot access them. Okay, you need to use your interface handle. Now in your top module, what you're going to do, so in your top module, if you want to use your interface, you need to create the instance of your interface. This is the main important step. So if you want to use the interface, you need to create the interface instance. Create the interface instance. This is the main point if you want to have it. Okay. So without creating the interface instance, you cannot use your interface. Okay. So how to create your interface? Creating interface instance is simple. So just write down the interface name. In this our example, it is INF followed by interface handle. Let's say it is INF underscore top and followed by empty brackets. That's it. So this is how you're going to create your interface instance. After creating your interface instance, what you need to do, you're going to instantiate your master inside your top model and slave inside your top model. You need to create the instance of your top model, create the instance of your slave inside your top model. Let's instantiate. So how we are going to instantiate? So master followed by instance name is dut, and you need to pass whatever the instance you have created, right? That you need to pass to your master, which is nothing but inf underscore top. Okay, and slave, let's say it is dut2 and inf underscore top. That's it. So you have created your master instance and you have passed the interface instance, and you have created the slave, and you have created whatever the instance you have passed it. So this is basically pointing towards the interface handle which you have declared over here, and this will also be pointing towards the interface handle you have created over here. Is it clear, guys? Is it clear? How you are going to use your interface inside your project? Is it clear? Basically easy. So whatever the signals you wanted to use, that particular signals you need to declare inside your interface. That is step number one. So inside your step number one, you need to declare your signals, whatever you wanted to use inside your interface. Now, the step number two is declare your master or whatever the model you are going to have, and just insert the arguments without instead of writing input A, B or input logic, whatever the signals you have, just write down the interface name and followed by interface handle name. Okay, using the handle name access the signals and write down your logic. Okay, and inside your slave module or whatever the model you wanted to use, there also in the arguments just use the interface name and followed by handle name. Using the handle name only access the signals which you have. Yeah, I'm coming step by step again, that's why. So the step one is declare your signals whatever you wanted to have inside your project. Declare all the signals inside your interface. Next, inside your master or whatever the module, declare the interface name followed by interface instance handle name. Okay. Now using this handle name only access all the signals. And inside your slave also, instead of declaring all the signals in the arguments, declare the interface name and interface handle name and access all the signals using this handle name. Now, before going to use your interface instance, you need to create the before you going to use your interface, you need to create the instance of your interface. That you are going to do it in the top module. Now, how to create the instance of your interface? Using the interface name followed by handle name followed by empty brackets. This will create the instance of your interface. Now, whatever the instance you have created, that you need to pass to your master, okay, and that you need to pass it to your slave. That's it. Now is it clear, guys? Where we have to declare interface in design block or in the test bench. We haven't started with any design or test bench. It's a separate file. Interface can be a separate file. Okay. It's a .sp file. I think Bhuvanesh, is it clear now? And others also, is it clear? So whoever is listening it for the first time, or is it clear, guys? Yes, interface is synthesizable. Okay, I need responses, guys. Please respond in the chat box. Is it clear? Okay. Now, I think someone might get some doubts by now, but I'm not getting any doubt. If you are listening this for the very first time, you need to get one doubt now. Okay. In our code, which wherever we have declared inside our code, have we given the directions to our signals? We are declaring the interface, but have we given any directions to our signals? Exactly. That is what I was asking about. No. So whether this code is going to work or not, yes or no? If we are not giving any directions, is it going to work? Waiting for your responses. Obviously, it will work. There is no doubt in that. Okay. So without giving directions also, it is going to work. Okay. Now let me show you one example for this. Let's say if I'm going to have a example of a full ladder using an interface. Okay. Let me have, uh, let me copy this. I hope my screen is, okay, let me share my screen again. I hope my screen is visible, right? Yeah. Now, here in this particular code, what I've written over here is, let me 1 minute, end this and end module. So in this particular code, we have simply declared a half adder. Okay. This particular half adder, here I'm not using any interface instance. Just I've written A, B, S naught and C naught and S naught, C naught and just written the half adder code. And in the full adder, I'm using the interface handle. See, so FA underscore IF, INF. Haven't declared any full adder related signals. Full adder related signals are declared in one file which is known as interface. Okay, so instead of creating multiple files, I've written everything in the same file. You can do this, or you can create multiple files for multiple modules. Okay, now how to create multiple files for multiple modules and how to merge them, I will show you. But in this particular code, I'm just writing everything in one file itself. Okay. So I've written interface followed by interface name is FA underscore IF. And I've declared logic A, B, C and outputs as logic S underscore out and C underscore out. I haven't declared any inputs and outputs. Okay. Now here, in when I'm declaring my full adder, if you carefully observe, I'm simply written interface name followed by interface instance name. Okay. And I've written S naught, C naught, and C1. Okay, let me take one simpler example. This is also complex to understand if you're learning it for the first time. Let me declare a simple half adder. Okay. So what are the signals which we have for the half adder? So let me take a interface first, which is H underscore IF. Now we have the signals as logic A, B, and logic sum and cout. These are the signals which we have for our half adder and followed by end interface. Okay. So for the half adder, which I'm going to have only these signals A, B, sum and cout. Now let me declare the code for my half adder module half underscore adder. I'm going to declare just my interface name and followed by handle name which is INF, and I'm going to write down assign INF dot sum is equal to A XOR with B. I cannot write A XOR B. I need to use my interface name which is INF dot A XOR with INF dot B. Okay. This A is present inside your interface and B is also present inside your interface. You are referring to them. Okay. And followed by end model. Up to here, is it clear, guys? I hope this is clear, right? This is very simple. I've just declared my interface and I've used my design and I'm accessing my signals using the interface handle name, right? Yeah. Carry also, let me write it down. So I assign inf dot cout is equal to inf dot a and with ab inf dot b. Okay, A and with B. That's it. Okay. Now, what I'm going to do, I'm going to write down my test bench module TB. Inside this module, 1 minute, getting some disturbance. Yes. So, yeah, exactly. There is no direction. Here, I haven't written any direction. Okay. Now, in my test bench, what I'm going to do, in the test bench, I'm going to create the instance of my interface. How to create the instance of my interface? Interface name followed by handle name. You can give any name and you can simply write it down. Interface name followed by interface instance name. Let me show you in the PPT. So what we have written over here, interface name, interface handle name followed by simply empty brackets. Okay. So what I'm going to write down, simply empty brackets. That's it. Okay. Now this handle. Okay. Now I need to create the instance of my half adder. In my test bench, how to create my instance half underscore adder, and let's say it is the instance name is HA. And whenever I'm creating the instance, I'm passing the instance of my interface. How to pass it? Just write down INF. Just pass the handle so that this handle will be copied to this. That's it. Okay. And if you want to drive your test bench, so what is that you are going to do? Initial begin inf dot a is equal to one tick binary one, and inf dot b is equal to one tick binary zero. Okay. And end module. And if you want to print them, how to print it? Dollar display or dollar display the value of sum is percentage d comma inf dot sum. Okay, so this is what I'm going to drive. Okay, that's it. So is it clear, guys, how to use your interface in your code in your project? Is it clear? Any doubts or any queries in this? So how many times we have declared our signals? Only one time, that is in my interface I have declared. That's it. Nowhere I have declared my signals anytime again. If you are not going to use your interface, if you are not going to use your interface, you need to declare your signals inside your half adder, inside your test bench also. Okay. So here only four signals and two modules. It's very simple task. But if you are working in really some big projects, interface is like your savior. Okay. So it will really help you. Okay. Yeah. So this is how you're going to use your interface. Any doubts? Yeah, it will work. It is not going, it is going to omit it and it is going to work. Compiler will not give any errors, or it is not going to restrict us if it is not, if we are not going to use Modport. Okay. But if you are going to synthesize, you might get errors in the synthesis. In the synthesis, you are going to get errors because you haven't declared any directions, right? Yeah, that is why if you use your mod code, then only your particular interface will be synthesized. If you're not going to use your mod code, then definitely it is not going to be get synthesized. Okay. Yes. Any other doubts or any other queries? Yes. So in our particular session, we have started with discussing of our interfaces, and we have seen how to declare your interfaces. But the thing which we have seen is we haven't declared any directions for our signals. We haven't declared any input directions or output directions or something, right? Now in our next session, we are going to discuss about something known as mod port. Okay. Using that particular mod port, we are going to have uh, we are going to give the directions to our signals. Okay, whether the particular signal is input or whether that particular signal is output to with respect to that particular model. Generally that will be little bit confusing for one who is going to learn it for the very first time. We need to have the signal direction with respect to of that particular model. Okay. I will explain you in detail about in that particular in tomorrow's session. And also we can also use interfaces inside our tasks. Sorry, we can also use our tasks and functions inside our interfaces. Okay, so how to use them we are going to say, and we'll also have something known as clocking blocks. These are for basically timing purpose. Okay, so we are going to discuss them all, right? Yes. So that's about this particular session. If you have any doubts or any other queries you wanted to